Good afternoon, everyone. I believe you learned a lot from the morning section. Our afternoon section will be kicked off with Dr. Christopher Steger's talk on statistical learning. And it's my pleasure to introduce Dr. Steger, who got his Ph.D. here at Rice under Dr. Behnaam Aazhang and Dr. Ashu Sabharwal. And his impressive experience after graduation includes working on positioning system at the startup of Skyhook Wireless, and later the development of a suite of products on mining mobile location data. Currently, he's the director of product innovation for personalized systems at Netflix, which is a company I believe have helped most of us in terms of life-work balance. So let's welcome Dr. Steger.
Thank you very much for that kind introduction. Usually when someone calls me doctor, I'm about to write a check. So I'm sure I'll be hearing from the development team. Okay, so thanks for being here today. I got a couple of questions about what exactly my role means. I'm a product manager at Netflix in charge of part of the personalization system. So maybe I'll start with a little bit of history about Netflix, and yeah. I understand that the students were compelled to be here, so I'll try to make it worth your time. All right, so for those of you of the younger generation, I should probably explain this. This is where Netflix started out, and these are digital video discs, which were a physical medium for storing movies. They were transmitted through the US Postal Service, and I remember when I was in grad school, this was kind of a big deal. You could get unlimited movies, and it was really fun, and so Netflix was net because it had a web interface where you would queue up the movies that you wanted, but then they would still come through the mail, so it was a fairly low bandwidth connection. And these were a really big deal at Netflix, these stars. So whenever you were picking out videos, you would say what you thought of them with your star rating. So the Netflix catalog was maybe hundreds of thousands of DVDs. So in order to wade through that, they needed a recommendation system, and you supplied stars so that Netflix could have some idea of what you like. Are you into zombies? Are you into Barbie? And guide you to at least the right region of that catalog. So Netflix took stars so seriously that in 2006, they did a thing called the Netflix Prize. And the idea was to improve the star predictions. So this was an RMSE-based metric saying, okay, our predicted stars minus the actual stars, et cetera. And Netflix said, if you can improve the baseline model by 10%, we'll give you $1 million. It's back when $1 million was worth something. And it took like 3 years for someone to hit that benchmark. And one of the big learnings was this, some advancements in techniques of matrix factorization. So you can think, you make a big matrix of users and videos, and then you want to be able to predict what the rating would be for each user video pair. So the basic intuition is you take this big sparse matrix, you project it down into a lower dimensional space, and that helps you to do collaborative filtering, which infers ratings from similar members or from similar movies. The other big learning was that you shouldn't just use one technique, you should do an ensemble of techniques, and that's what the winning team ultimately did. They were a merging of multiple teams that had tried different approaches, some of which were better than others, but together they were incremental. So in the end, they called themselves Belcore's Pragmatic Chaos. I think that was like 3 different names stuck together. And anyway, they won the $1 million. So happily ever after, we have Netflix recommendations, the end. I think changed after that. And hopefully I don't make anyone dizzy with this. It's lower resolution than I initially realized. But something changed in about 2007, which is Netflix started offering streaming. And on the face of it, there's no big difference there. It's just movies. But by having the play button on the website, we suddenly have a much richer interaction with members. So instead of just getting your explicit feedback of the star rating, now you press the play button and we see what happens. Like, did you actually watch that thing? Or do you just think you're supposed to like it? Some very cerebral documentaries would get very inflated star ratings when people didn't really want to watch them. They just wanted to be the kinds of people who watched cerebral documentaries. But now with the play button, we're able to have a much more nuanced look at how quickly you play, how completely you play. So that made it a much more interesting problem. So one thing leads to another. We launched in 190 countries. We're over 140 million global accounts now, which with account sharing means like hundreds of millions of people watching. And according to Sandvine, taking up like 35% of the peak download bandwidth in the US. Thank you for streaming. And now we've gone from valuing a 10% improvement in the personalization system to valuing personalization for the Netflix business at about $1 billion a year. And this number is now a couple years old, so I'll assume that it's inflated because it serves my own interests. But you'd ask the question, like, why is it worth so much? And the answer is we can actually prove it empirically. We test to see whether people have a better experience with personalization or without. And you can measure that people retain their accounts more at the end of the month if they have a personalized experience. Very empirically provable. So maybe the more interesting question is, how do we do it? So how do we go from this sea of videos to this, or this, or this, depending on who you are? And given the trends of the day, you'd probably assume that I would just say some sort of Death Star deep learning model that just takes in all the data on one side and then spits out Netflix on the other side. And I can't prove to you that that's impossible, but even for like the biggest deep learning models, the dimensionality of this problem is really vast. And if you just go ahead naively, if you just say, I'm going to take a picture with my phone of a page that I like, and then you tell me how to get that, that's a very difficult problem. But there's a lot of structure in this problem, and that's how we're able to simplify it. So when you look at this page, you can start to infer that this is not just a totally naive optimization across the whole catalog, because you have a relevance ranking in each row context, so that row has some meaning to you. And the rows themselves carry some meaning, the labels on them, the reasons why they're grouped together, and that has a higher or lower relevance for you. So one sort of contained example of how we're able to break down the whole Netflix experience, the whole personalization problem into a trackable unit is image optimization. And I don't know how many people are actually aware that we're doing this, but for any given image, or for any given video, we come up with a lot of images. So before we sort of paste the images on the top, we come up with a logical page. We say which videos should go into it. But then there is that one more question of, if we think you should watch Stranger Things, or we think you should find out about Stranger Things, which of these images is going to be most compelling to you? So this is just a subset of the different ways that we could convey what Stranger Things is. As I was saying to some folks earlier, Netflix has more and more of these new videos that have never been heard of before. So we have to explain, like, what is this thing and why would you want to watch it out of the thousands of other videos? And images are a very important part of that. And by isolating the image problem and taking the learnings from the sort of basic Netflix recommendation systems, we say, okay, what is an embedding space that we could use to describe these images? And we don't even need metadata. We don't necessarily need computer vision to start to do that. We look at co-occurrence. We say, okay, let's explore with these. Let's show them to a lot of people and see which ones get played more. So what are the baseline more popular images? And then let's go one more step and say, who is playing which image? So is there something in your play history that can predict which of these images you're going to like more? So in this case, one intuitive example is we could show Goodwill Hunting to you a couple of different ways. Goodwill Hunting may be too old for me to continue using this example. But it's got Matt Damon. He's the sort of romantic lead. And it's also got Robin Williams. He's sort of the mentor character. So there are a couple of different angles through which you could come to be interested in Good Will Hunting. And they could be reflected in your play history. So are you more into the sort of romantic shows? Or are you more into the sort of edgy comedies that might have led you to be a Robin Williams fan? And so that shows up in your play history. We embed you into that latent space. And then we put those images into the latent space through co-occurrence. So it didn't require a deep learning Death Star to do that. It required embeddings that we had just basically built up on the shelf for our other recommendation systems. So here's another example, search relevance. So Netflix has a lot of videos, but it doesn't have all the videos. And we certainly don't have videos that map exactly to every different term that people would use to search for them. There are a lot of different ways to say you want something. So we have this many-to-one kind of mapping from search terms to our catalog. And it's noisy that way, so maybe many to many. So we have to figure out, for any given search term, what should we show you? And for some search terms, that's not obvious. For some, it is. But as we come up with metadata to apply to these videos, we don't necessarily get all the words that people might use. So it's great to have an empirical algorithm that can say, I'm going to take an arbitrary query and look at co-occurrence with video plays and embed the queries in the video space that way. So here's one example that I'm proud of, where our system actually learned the term plot twist. So just by some quirk, our metadata teams didn't use the term plot twist, so we didn't have it pre-populated in our search query database. But then we started to find co-occurrence between the term plot twist and these videos. So just by following what our members were doing, we were able to learn this concept of a plot twist. Here's another one that totally confounded us early on. There were so many instances of A. And honestly, I thought some members were just kind of being jerks and like messing with the search system, trying to break it. It turns out they were pre-literate kids just button mashing on the remote. They were saying, give me a movie, give me a movie, give me a movie. And usually what they meant apparently was Moana. So it's an example of giving the people what they want just by following the empirical path. Okay, so who gets to work on this? Ed asked me earlier, like, well, this doesn't sound very much like what you worked on at Rice. So how did you happen to go here? And that was, I was similarly confused. When the Netflix prize came out, I thought, well, that's not really what I'm working on. That sounds really neat, but I don't know how to do that. So I guess I'll just see what happens. I'm relative to my own graduation date, which is the beginning of this curve. You can see the growth of terms like data science and machine learning and deep learning. Some of those things didn't even really exist in the popular consciousness when I was graduating. But they've grown up a lot since then. So you have all these people who graduated in approximately my era who are now doing this. So how do they do that? So I did a non-scientific survey of the personalization team in my immediate area for their thesis topics. And doubtless you've all reviewed my thesis, thank you. So you'll see that there. But you see just a wide range of different topics. We've got 2 component galaxies, understanding the multiple stellar components of observed and simulated galaxies. Here's one that's really long, but it ends in applications to the Colorado River Basin. So we have this incredibly diverse group of people who just have the basic skill set to be able to solve hard problems. In terms of their major fields of study, there are a lot of electrical engineers, a lot of computer scientists, but also a sizable number of physicists and economists as well, because they have a lot of learning about causal inference. Okay, now I have to, I'm coming back to my alma mater. I have to give you a pontification warning. I'm going to offer some advice. So if you're not interested, you can wait till the end. There will be clapping. Okay, so there was this article from Mark Anderson in 2011, Why Software is Eating the World. And this was a very bold statement that now I think we can stipulate as fact. an incredible fraction of our daily experiences are governed by software. And I would even go one step further and say that machine learning has also eaten the world by now. We have lots and lots of algorithms driving things around us. So what I would add to this is that statistical hypothesis testing is also eating the world. And this people may be less aware of, and it's relevant to the kind of studies that you do today. And that's because all the companies like the Googles and the Facebooks and the Netflix and the Pinterest and all the other big consumer products companies, all the services and software are doing tons and tons and tons of A/B tests. And they need principled ways to set up those tests, evaluate those tests. So really your experiences, the products that you touch every day are being built out of many, many, many statistical hypothesis tests. So being able to state those rigorously and evaluate them is super valuable. We spend a lot of time and money and talent on that. So if I could offer some advice for things to get done before you leave Rice, understand probability and statistics. Like that's super key. When I left Rice, I thought, okay, I have a pretty good grounding like estimation and detection. And then I encountered a different set of terminology, and I was like, oh, wait, that means I also know regression and classification. Okay, I get it. I can pretty much do this. Or, okay, I can construct a naive Bayes classifier. So it's probably not a great leap for me to understand logistic regression. I've done some basic gradient descent kind of algorithms. I understand this epsilon step of doing machine learning. Okay, I understand logistic regression. It's not a great leap to go to learning a neural net from there. So once you have that basic understanding of probability and statistics, linear algebra, so the MIMO channels, all the stuff you learn in that part of your studies has vast applications. And finally, learn to write. If Ashu spills red ink all over your paper, he's doing it out of love. That was really good for me, and it's really important to be able to clearly communicate what it is you're trying to do with those hypothesis tests. I'd say at Netflix, Amazon, companies like that, we have more and more of a memo-driven culture. So even if you end up in industry, you will keep writing. And finally, thank your professors. They are preparing you well for the world. And finally, for your mental health, please keep watching Netflix. Yeah.
So if I was to design a better prediction algorithm for Netflix, could I get $1 billion?
Well, it hasn't worked for me yet. Anybody else? Yes?
To what extent do you try and take into account certain dimensions that might be harder to capture? I guess one thing I'm thinking of is, I know a lot of people who use Netflix in sort of a couple different modes, right? Like one person will have Netflix on in the background while cooking or cleaning, and then when it comes time, like, oh, in the evening they want to actually sit down and watch a movie or a series. It's a more serious, like, I'm going to watch Netflix now. It's obviously not something, well, I don't know, maybe it is something you can somehow track. Is there a way that Netflix tries to read into that and say, oh, I'm going to try to recommend something that you're actually going to watch versus something you might like to have on in the background?
So there are a lot of different ways that we develop hypotheses for how members are interacting with the system. So that background watching hypothesis is one of them, and we go out and do qualitative research and say, what are you doing right now? What if you were folding laundry? What would you put on? So we form hypotheses that way, and then we say, okay, what sort of a metric would tell us that a user was in that mode right now? Like maybe they don't interact very much. Maybe there are certain types of shows that they go to. Maybe they repeat watch something like Friends over and over again. So we can hypothesize those types of interactions, and then we say, okay, if we make that better, does it pass our hypothesis test that we have improved the member experience? They're getting more out of Netflix. We're changing their behavior. They're demonstrating to us that we're giving them more value. So there's a chain by which we can get to those kinds of mechanisms.
Are you guys working yet? There's one show where you can during the show changed the plot.
Yes,
Are you
Bandersnatch.
working on dynamically changing the plot, without any user input?
So what I can say about that is that throughout the product, there's always a sort of a healthy tension between what we do automatically and what we encourage users to do for themselves. So whenever we do something automatically, we're kind of taking away choice, but maybe it's delightful. But sometimes the better answer is to let people choose for themselves. So that's an area where we're actively exploring.
Seems you mentioned DVDs. I'm one of those old guys. My wife got a Netflix a subscription like right at the start. Got a real good deal. We still have it, and we still get DVDs, right?
Yeah.
And one of the things that we notice is the DVD catalog back then was way more quirky, way more diverse. Mm-hmm. The Netflix online is like the 12 things that everybody in the universe wants to watch, mm-hmm. plus whatever Netflix makes. And I wonder if that's a marketing strategy or if it has something to do with your search engine, like you've taken all the interesting movies out because nobody watches them or something.
I'd say business-wise, the companies are pretty decoupled. So getting streaming rights versus getting rights to send out DVDs is pretty different. So I'd say the catalogs have developed around what's feasible from a business perspective. So it's not intentionally judging.
I think one of the challenges that prediction and ratings may have is when families or like 20 college students share like the same Netflix account. How do you have like models that sort of differentiate the fact that like, okay, now this user's watching, or like just being able to split like preferences from one individual versus like understanding, oh, there's a family with a child and their recommendations based on that?
Don't worry, I won't tell. Yeah, there are some clues there in terms of devices, time. There are patterns that can allow us to believe that there are multiple latent individuals behind a single profile. Now, what we should do about that is another question. Should we adapt aggressively to say, oh, we recognize this phone as being different from this phone, so we should split those recommendations? That's another area of exploration. I'd say there's plenty of evidence of account sharing and profile sharing, and it's a really interesting modeling problem. It's a really interesting business problem.
There is a question that I want to share, as many people spoke before. Trends, passwords, profiles of clients. How would you secure that data, and how are you exploring blockchain to apply in the near future?
That's not at all my area, so I can't really comment on security stuff. I really appreciate our security team for making it so that we don't have big blow-ups about that kind of data, but it's really not something I work on. Okay.
So all these co-occurrence models seem like a static model. Like, how do you model like evolving user preferences? Like, he may be shifting genres, like, so. Mm-hmm.
So there are a few different ways to do that, and one of the nice things about ensembling is that we don't have to choose just one. But the one naive way to do it is to window your training data, say only look back at a certain window. Another way to do it is use an RNN or other kind of stateful model that has some rate of forgetting. But like I said, we end up kind of picking all solutions and counting on our ensembling models to balance them against one another. All right, thank you, everybody.